Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I'm sure some of you, at least, are well aware of the meme out there that goes something to the effect of what my friends think I do, what my boss thinks I do, what my mom thinks I do, what I think I do versus what I actually do. You know, the ones where it has like 5 or 6 different images of, a certain profession and different states of, what people actually think they're doing. There's some pretty good ones out there for like computer programming and software developers and whatnot. There's of course always one of the images is like a hacker man or something. So pretty good stuff. But what I wanted to do for this episode is kind of give a real world view of what software developers and software engineers actually do. Because just because you call yourself a software engineer or a software developer or a computer programmer or whatever, there's a bunch of different like subcategories or different niches that you can kind of fall into. And some of these kind of career paths, I guess you could say, aren't necessarily even strictly like software development focused. Like some of them are kind of more like you take concepts that you learn in like a computer science degree, for instance, and use them, but you're not like specifically writing code or writing a lot of code. So that's what we're gonna get into in this episode. But before that, let's start with our trivia question. UEFI is a specification that defines the architecture of the platform firmware used for booting the computer hardware and its interface for interaction with the operating system. What does UEFI stand for? So a similar question to last week's trivia question about the BIOS, but this week we're talking about UEFI, which is kind of like the newer version of the BIOS, if you will. But yeah, so what does UEFI stand for? And that is the trivia question for the week. You know, one thing that we're actually going to kind of get into, which I didn't plan this per se, but kind of thought of it like pretty much just as I started recording, was the fact that UEFI and like firmware and that kind of stuff is like a portion of like some software engineering, like in software development, like what you can do as a career path, like developing firmware and things like that is one of the possible career paths. But we're getting ahead of ourselves. So before we get into that, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, this one is we constantly talk about, the need to monitor incoming connections and, to make sure you have things like a firewall in place and DMZs or demilitarized zones or other means to try to prevent things from getting into your network. So you do it using something like an intrusion prevention system or detection system, things to identify suspicious activity coming into your network and potentially stop it in order to protect yourself from cyber attacks. But one thing that sometimes goes overlooked is you also should be monitoring what goes out of your network rather than what's just coming in to your network. Now, depending on how you configure your intrusion detection or prevention system, you could potentially have it configured to monitor traffic locally on the network to potentially, catch things like this. But the reason why it's important to also track what's going out of your network is because one common thing that malware likes to do is phone home to some kind of control server. This is specifically seen in like DDoS or distributed denial of service attack botnets. So commonly what will happen is when a device gets infected to become part of a botnet for a DDoS attack, it will essentially listen and talk to its command and control server, which is somewhere else in the world, and then that command and control server will be like, hey, go attack, this IP address or this domain or whatever, and then your device that's been infected with the botnet will then go and flood that site with traffic, and along with all the other devices in the botnet, and thus, try to take down that site. So one thing that you can, try to look for is if you're monitoring your network and you notice traffic or connections to unknown domains or unknown IPs, that could potentially be a red flag that you might have some kind of infection on your hands. Another thing, like in addition to botnets, other malware in general can reach out to a remote server. Things like ransomware, it's typical for that to reach out to a remote server. So any kind of unusual or odd traffic that you see going out of your network, or basically things that you don't recognize, could definitely is not necessarily a guarantee, but could be an indication that somewhere on your network malware got in and infected one of your devices. So one additional thing you can have in your back pocket is to be sure to check not only the traffic that's coming in, but also the traffic that's going out as well. And that is your cybersecurity tip for the week. Also, kind of ironically, we do have some networking related things and security related professions for software engineers. But again, we're getting a little ahead of ourselves because first we have to get into what nerdy stuff have I been up to this week. Now, if you listen to last week's episode, I already spoiled what this week's episode is going to be, because last week I talked about my next steps for essentially my memory watcher, if you will. I'm not sure if I gave it a specific name, but I've internally dubbed it my memory watcher, and integrating that and my automated test cases into a GitLab CI/CD, or continuous integration and continuous deployment pipeline. So the first thing I got working was the automated tests, because that was already ready to go and everything. I didn't have to worry about doing any additional integration for that. It kind of worked. So the initial phase of getting everything to build was fairly easy, mainly because I already documented everything in regards to like what dependencies you need to install in order to build the project. So all that was pretty straightforward. And of course, I have make rules defined already to build the kind of package I want to make, in this case, the test suite. So that was pretty trivial to do. The place I ran into an issue with, though, was getting the artifact that was built during the build phase to transition properly into the test phase of the pipeline. And I was debugging this for longer than I'd cared to admit, only to realize the main issue of why this wasn't working was the image I was using for the pipeline. I specified, I think it was the GCC image for the build phase, and I didn't explicitly specify an image for the test phase. So for some reason during that transition, even though in theory the artifact should have been being copied into the new container, I guess, if you will, and I could even see it, like if I did an ls during the pipeline, I could literally see the test executable just sitting there, but whenever I tried to access it, it would be like, nope, can't find it. So not entirely sure what the issue was there, but what ended up solving it was just ensuring I was using the same image for both the build and the test phase. So if you're running into any issues with the GitLab CI/CD pipeline with things not being copied properly from one phase to another, that could potentially be your issue. So that was kind of one of the issues I ran into. But after, troubleshooting that and getting a bunch of pipelines to fail on me, I finally did get it working. And then, of course, I couldn't stop there because I needed to ensure that what happens if the test case fails? What happens if I fail a test case for some reason? Does the entire pipeline fail? Because that's the desired output. So, of course, I went ahead and tested that. The commit history is actually quite funny because, us developers, we like to have a little fun with our Git commit history. If you've ever looked at commit history before, sometimes you'll see some fun little tidbits in there. But anyway, the first commit, I think, was something like intentionally failing the test case to, in parentheses, hopefully cause the pipeline to fail. And then, of course, that actually successfully caused the pipeline to fail. And then the next commit was reverting that change and saying, it worked. Okay, back to normal now. Or something to that effect. I don't remember. I don't have the commit exactly in front of me. But that was essentially what it was. So, of course, I had to have a little bit of fun with it. And the funny thing was, too, was that was like the first time I actually saw the pipeline fail when I actually wanted it to fail. And it was kind of a fun win. But then, in addition to that, as I mentioned, I got the memory watcher integrated into the automated test suite and got it all configured properly in the makefile to include it and not to include it, to basically just make sure that I'm only using the memory watcher when I want to be, to analyze memory usage, otherwise to not use it, because for optimization and performance reasons, it's best to just use the built-in ones rather than trying to roll your own in some kind of wrapper solution like I'm essentially doing. But overall, it's working pretty well. There have been a couple kind of little bit of hiccups that I've kind of noticed in regards to a little bit of funkiness. But overall, it's doing pretty well. One thing I kind of overlooked was the fact that there are instances where you have to account for memory being allocated before the memory watcher is instantiated or before it's initially set up and created, and also for memory that goes out of scope and gets deleted after the memory watcher goes out of scope and gets deleted. So there were some issues where there were some issues where I tried to allocate memory before things were initialized in the memory watcher, which was causing things to error for obvious reasons. I was getting all kinds of null pointers because the things weren't initialized yet, so they were just all zeros. So when you try to access a null pointer, you run into issues. So had to fix that, and then had a similar issue on the back end where when the program would go to exit, it would again sometimes try to access thing that wasn't there, and so that wasn't all that tricky to debug. That, of course, again, it took me longer than it probably should have, but I did end up getting that working. And the other kind of quirk, I guess, I noticed with it, which I have a kind of a solution in place, I just haven't had a chance to implement it yet before recording this podcast, is the memory watcher, of course, is indiscriminate as to the memory it's watching. And essentially what I mean by that is there are some cases where in some of the test cases, the test case will allocate memory in a global space, or there is a global variable that's supposed to exist throughout the course of the entire program, the entire game, essentially. And these specific test cases are allocating memory for that global object. And then that global object gets cleared and removed and cleaned up, once the program exits. And the issue is the memory watcher doesn't know about that. So all it sees is the fact that you allocated, say, 64 bytes of memory and you only ended up freeing, 24, whatever the case may be. And it's like, oh, yep, you got a memory leak, even though in reality you didn't, because you cleaned up all the local memory. It's just the memory that still exists is in a global space. So that was kind of something I'm trying to work through. I have a solution in mind, but I haven't got it completely implemented yet. Essentially, what I'm planning on trying to do is create an initialization thing for the memory watcher. So essentially, the memory watcher's going to be always running, but only capture memory allocations during specific portions of the program's runtime to at least try to be able to better control the allocations that are being made and to more easily identify which ones are from a global space versus which ones are local, and try to keep it mostly to the local space. Now, one thing I noticed was ironically, one of the issues that I was running into was my check to see if I leaked memory was if the start amount of memory allocated was equal to the end amount of memory allocated, which in theory that's how it should be, right? Whatever memory you start with, which in theory should be 0, but in my case it wasn't because some global memory got allocated before we got to the automated test cases. But anyway, that's besides the point. The issue was actually when we got to the end, there was a time where I was actually had allocated less memory than at the start, and because the start wasn't equal to the end, it thought there was a memory leak, which in reality wasn't actually the case. But the issue I found there, and why I kind of wanted to come up with this other solution, was because if in theory there is a chance that if you deallocated some memory in the global space but leaked memory somewhere else, there's a chance that you could have a net 0 but actually have a memory leak because the delta ended up being 0 or maybe even less than 0, but you actually ended up leaking memory. So again, this feature, this tool is definitely not foolproof by any stretch of the imagination, and that's why for legitimate hardcore memory testing, I'll probably still stick with a tool like Valgrind, but at least this is a good tool to at least catch some of the more noticeable or memory leaks that'll definitely stand out and you'll notice. But yeah, so that was what I got up to this week. And now let's get into those career paths that I've kind of teased throughout the beginning portion of the episode. So there's a saying out there that I've heard, and some of you that are software developers might also have heard, that goes something along the lines of none of the best software developers actually write code. And if you're wondering how that is the case, in the short version is because they were so good at writing code, essentially they were so good at their job, they got promoted so much to the point that they don't actually write code anymore. Now, this partly depends on where you work and what company you work for. But in my personal experience, there is a little bit of truth to this statement. Of course, there's going to be outliers in every case, but there have been some experiences in my personal professional experience where I've come across some insanely talented developers that, quite honestly, I didn't even realize they were developers because they weren't actually writing code. But then I got, a tip that, hey, this person might have some insight that you could pull from. And then, I go to talk to them and, lo and behold, they were the one that wrote, most of the code base back in the day. So there definitely is some truth to this, but there's also been other cases where, I've talked to, more senior devs that are, absolute geniuses, and they're still writing code. So, of course, there is some truth to both sides. But the reason why I kind of bring this up is because there are cases where you can go to as a software developer, a software engineer, that aren't necessarily strictly for writing code. And we're going to kind of get into those. Now, personally, I think writing code is more fun than some of those other positions, but I guess I'll let you be the judge of what you think is more fun or less fun. So the first one on the list is a freelancer. Now, this is a very, I guess, broad kind of bucket, you could say, but the idea here is there are sites out there that exist that you can essentially give your services to, where basically kind of like freelance contract work, where companies can just hire you on like a contractual basis to maybe build a website for them, or help them out with something else, and essentially just kind of make some money on the side, working just get kind of gig work, if you will, in a way. Not really like you're working full time for a company. You're just kind of doing it kind of on the side, like side gig type stuff. The next one on the list is an indie developer. Now, again, this is kind of also a broad ranging field, but when I'm talking about an indie developer, essentially you're just kind of on your own developing, kind of what you want to do kind of in your spare time, in your free time. You're not necessarily doing this as a full-time gig, although there are definitely indie developers out there that make a living off being an indie developer. But essentially what an indie developer is you're just kind of a one-man team, just, working on code. Maybe you have some supporters out there that, help pay to allow you to do what you're doing. But in general, an indie developer is just kind of out there, doing their own thing and, working on their own project or maintaining their own open source repo or something like that. The next one that has been all the rage these days, at least the past few years anyway, is a machine learning engineer. So very fancy. Essentially, kind of the point here being you're developing and creating and using machine learning models, but specifically on kind of the designing and building aspect. So, working with things like TensorFlow and PyTorch or other machine learning technologies in order to kind of design and build these machine learning algorithms, and then also kind of like optimizing for performance. So trying to find that balance of training your machine learning algorithm to be good enough, but also not overtraining it to the point where when you give it just kind of more generalized data, it kind of falls apart, if you will, for a lack of a better term. And the next one here, I kind of have broken down into some subpoints, which is software developer / software engineer, which kind of defeats the whole purpose of going into careers, because that is literally what we're trying to go into. But specifically, I kind of wanted to touch on some of the more core focused in kind of the typical, if you see a job posting for a software developer or software engineer, kind of some of the more, I guess, jobs you'd kind of see focused. So, of course, one of the first ones is mobile. So, like a mobile software developer, a mobile software engineer, focusing more on like iOS and Android app development. So you'll probably be working with languages like Coltan, which is kind of the new kid on the block for like the Android world, or working with Java, Swift, or if you're working on a legacy code base, maybe Objective-C, but working on, those mobile apps. And then the next one is kind of a broad brush scoping thing, which is web development. Now, this is kind of, you can break this down into a couple of different buckets. You have your kind of general web development, then of course you have your front end, your back end, and then the full stack, which is basically front and back end. But essentially, your front end's kind of all the user interface type stuff. And then the back end's kind of that back end server stuff. Both are probably going to be using JavaScript. But then on the back end, you might have something else like maybe Go or potentially Rust or C++, maybe some other kind of backend to run the server. And then the front end, you got your JavaScript as well, but also things like your HTML and your CSS. Then you probably have your fancy framework, whatever it is, whether it's Angular, React, Vue.js. I don't know how many there are at this point, but there's a lot of them. Pick whichever one you want. And then, of course, there's full stack, which basically tries to blend both of those worlds together. Also, kind of in this mix, you might also have something like Ruby on Rails, or Django for like Python. So there's a couple of different technologies and languages and flavors that you can use in the web sphere. I try to stay away from it as much as possible, but of course I do have to get into it every now and again whenever I want to update my website. But usually that's just like HTML editing, so how much coding am I really doing? Because some would argue that HTML isn't a programming language, but I will let you decide if it is or not. The next one, we get into a little more fun, which at least I think it's a little more fun, which is embedded systems development. So here you're mainly kind of writing software for, of course, embedded systems and kind of that firmware level type stuff. So kind of one of the one of the more famous ones in this space is like an FPGA, or I think that stands for Field Programmable Gate Array. I think I got that acronym right. The embedded systems that are kind of either out on the edge or running IoT devices or things like that. But you have your things like automotive systems, medical devices potentially, other consumer electronics, and this is also kind of where you get your ESP32s, your Raspberry Picos, your Arduinos, that kind of thing, like other kinds of microcontrollers. Because one thing that people like to do, in the home lab space is work with some of these like ESP32s or Raspberry Picos or Arduinos to control, parts and kind of develop a smart home kind of a thing with them, and link them into things like Home Assistant or control other devices or turn dumb things smart, that kind of a thing. So all that's kind of like your embedded systems. And specifically here, you're going to be working with lower level languages, of course. So you're going to be working with things like C, C++, probably going to be doing some assembly. You might be able to get into some more memory safe languages like maybe Rust. And I know Swift has made a push for like embedded Swift as well. And working with like RTOS or real-time operating systems. The only, I guess, issue with using some other languages that aren't C and C++ is kind of as we talked about, I believe it was even just last week, with C and C++ giving you that access, that physical access to memory, and being able to point to specific memory addresses very easily to manipulate things. Because one thing that you'll notice if you get into kind of any kind of embedded systems development is that's basically how you have to interact with the device, is accessing specific memory locations to perform certain actions, which is why languages like C, C++, and just raw assembly are very commonly used for those use cases. The next one is kind of in a similar vein, which is operating systems and kernel level development. So again, this is going to be a lot of low level code interacting directly with the hardware. And here again, you're going to be doing a lot of C and C++, and Rust has taken a decent chunk of the market share, I guess, too, being incorporated more and more into the OS and kernel level development. The next one is kind of one that I quite enjoy, which is game development. Of course, this is developing things like video games, pretty much the whole gambit of it, not just the writing the code for how things work, but also designing and developing the game, trying to figure out how the gameplay is supposed to work, the mechanics, graphics, user interactions, balancing of the game, all those kinds of things that go into developing a video game. And then you could potentially be using an engine like Unreal, Unity, or Godot, or maybe you're just going raw and just writing everything from scratch because you're too good for a game engine, or maybe you're just using, like raw graphics libraries and just kind of doing it on the fly, whatever the case is. But if you're in one of the, I guess, bigger game studios, the chances of you using an actual game engine compared to kind of doing it on the fly are probably pretty high. You're probably using a game engine. As far as language goes, there's kind of a range here. If you're using like one of the bigger game engines like Unity or Unreal, I think C++ or C# are probably the big ones. I think from my experience in the past of using Unity, which granted has been a while, I think C# was kind of the big language there. I'm pretty sure Unreal is more of the C++. And then Godot kind of has its own like scripting language to write games in, but I also know Godot's written in C++, so I'm not sure if you can kind of link the two and marry the two together. But regardless, those are some of the bigger ones. And then you can also like even write games in other languages too. Like I've written games in Java before. You can write games in Python. Pretty much the sky's the limit depending on what you're trying to make, but for the bigger game developers, you're probably looking more towards like a C++ or something like that, or maybe even C#. So those are kind of some of the more bigger software developer / engineer roles. There's of course many others, but those are kind of the bigger ones that I've kind of seen. Now moving into some other roles that are also kind of, roles that software developers can look into. The one here being a data engineer or like a database engineer or something to deal with kind of data. So this is kind of dealing with, the infrastructure and the pipelines of working with data. So you're probably going to be using things like Python a lot to do kind of like data analytics potentially, designing and constructing data architectures and pipelines, using tools like distributed file systems like Hadoop, and then using tools to be able to work, with those distributed file structures like Spark. And then, of course, using actual databases, whether that's, MongoDB, SQL, some other NoSQL database, CouchDB, whatever your database of choice is, Postgres, there's a lot of them out there. And then kind of going into the next one we kind of touched on a little bit earlier is the security engineer or the security researcher. So if you really want to kind of marry the software developing and cybersecurity worlds together, security researcher or security engineer is probably what you want to be looking for, because this is, of course, focusing more on, software and system security, identifying threats and vulnerabilities, writing patches for those, and just really digging into, source code and trying to identify security vulnerabilities and implement various security measures to ensure compliance for security standards, and then working with other tools and methodologies like firewalls, like we've talked about before, implementing intrusion detection systems, intrusion prevention systems, managing DMZs, all that good stuff, working with encryption. And then if you're really getting into fun stuff, potentially even doing penetration testing, where essentially you get paid to try to hack people. But of course, it goes without saying, if you do ever get into penetration testing, always make sure you, 1, have written authorization to do so, and 2, you have your get out of jail free card, aka the letter from whoever told you that you can do that, basically getting you off the hook if and or when you get potential law enforcement called on you or get into potential legal trouble because people are mad at you for trying to hack them. You basically have that thing that, hey, I was authorized to do so by this person. You can go talk to them and you can basically get out of jail for free. So always make sure if you do get into pen testing, you have that. But that is definitely an avenue that you can go down to if you're kind of looking to kind of marry the worlds of software development and cybersecurity, because one of the things and one of the reasons why security researchers are so important is because having good guys to be able to find these vulnerabilities to disclose to companies so the companies can patch those vulnerabilities means it's one less, avenue that threat actors can use to try to exploit us, us plebeians that aren't as savvy in digging into, the nuts and bolts of software and reverse engineering it and finding, these super minuscule bugs that can turn into, these massive gaping security holes if you exploit this, one minor flaw in this crazy over-the-top manner that you kind of think is impossible. There have been many of those, in the past few weeks and even months, where these exploits and vulnerabilities come out, and the means of actually performing the exploit is absolutely insane. And the fact that, people actually were able to figure this out and get it to work, at least in a, testing environment, is quite awesome and quite insane. So having those people on the good guy side is definitely nice to have. So the next one on the list is a systems or a software architect. Now this one is one of those roles that if you're good enough at your job, you might get promoted to, and just because you were good at writing code, so then they kind of promote you up the chain, and this is potentially where you might end up. So kind of the focus here is like designing software and designing systems and kind of trying to define and design the architecture of how things are going to work together and work with one another, rather than the actual implementation of it itself. So you're not necessarily the one writing the code, but you're kind of the one that's, designing the kind of how the components will interact with each other. So if you have a client server model, how they're going to interact, what's the protocol going to look like, what are your use case diagrams, your user stories, your user diagrams, all that fun stuff that if you're like me, when you kind of went through that in college, you kind of rolled your eyes and were bored out of your mind because you weren't actually writing code. It's, in my opinion, the more boring side of software engineering and software development, but it is something that's also important to have, especially if you're working, with a customer of some kind. Having those designs and those plans architected, written out, and agreed upon is something that's very important to prevent things like scope creep, for instance. But in general, of course, as we kind of mentioned, the goal and kind of job description, if you will, of the systems or software architect is defining the overall structure of a software system to make sure it meets like technical and business requirements, as we kind of alluded to, and also guide development teams in implementing the solutions rather than, actually, writing the code themselves. Although I guess there is still potentially a chance you might be able to write code, but again, that's not really the main focus of that position. And not necessarily in the same vein, but in a similar vein where you're not strictly writing code to be going into production per se, is a software tester. And this can kind of take a couple of different roles. You could either be like specifically testing software where you are just kind of given the software and you just try to break it essentially. But there's also kind of testers where you're writing code, but you're not writing code. And what I mean by that is like you're writing code to basically test code, right? So I've talked, the past couple weeks of essentially writing automated test cases. That's essentially what you're doing here for like being a tester, is you're essentially writing software tests to ensure that the software is meeting, quality standards, and ensuring that you're accounting for edge cases, and, someone can't just do an SQL injection to break your system, things like that. So kind of the main roles and responsibilities is, ensuring that you execute test plans and develop, some kind of testing procedure, whether that's automated or manual, identifying things like bugs, ensuring the software is meeting the standards it's supposed to. And then you might also, depending on what language you're using, you might be using some kind of testing framework like Google Tests or JUnit or something like that in order to write your test cases, so you're not necessarily writing them from scratch and you actually have a framework that you can build off of. The next one here is one that some people will like and others won't, and that is a Scrum Master. Now, the Scrum Master, of course, is more of an Agile specific, so we've talked about, the various kinds of software development methodologies, Agile being one of them, and the Scrum Master is essentially the one that leads the Scrum meetings, or kind of like the daily stand-ups, if you will. They also are kind of in charge of doing the sprint planning and retrospectives during each one of the sprints, so kind of leading the planning session of, okay, what items are we going to check off the board this sprint? Okay, this sprint just finished. How did it go? What went well? What didn't go well? Kind of leading those discussions. But usually, at least in my experience, the Scrum Master is kind of it's one of those roles that it's not like your main job, but it's like another additional hat that you wear. So it's not like, usually there's not like you don't get hired just to be a Scrum Master. It's kind of one of those things that you kind of get put in as kind of an auxiliary or additional, point to your job description. And kind of getting into these next two kind of go together but are also separate, that being a project manager and a technical lead. So there are some key differences between a project manager and a technical lead. So the project manager is, you're essentially managing the project, you're overseeing the project, so you're overseeing the developers, but you're also, interacting with management to, give updates on the status of the project you're managing, probably working with stakeholders or customers, to gain their feedback, kind of understand what they're looking for, identifying requirements, things like that, and ensuring that the project that you're supporting is, meeting the standards that, your customer wants. And then, managing other aspects of the project too. So maybe that would be things like financials, potentially, managing resources of, what developers are working on what, that kind of a thing. But technical lead is similar in the sense that you're kind of overseeing a project, but this is, more from that technical focus. So you're kind of, leading the developers specifically and not necessarily having to have that direct interaction with customers and clients and stakeholders and managing, financials and all that stuff. You're mainly focusing on ensuring that, the developers on the team are, following, good coding practices, ensuring that, you have good code reviews, you're adhering to the quality standards that you set in place, all that good stuff. And also kind of being a teacher or a mentor to younger developers, which is kind of the next one that I wanted to get into, which kind of technical lead and this kind of mentor teacher thing are two additional roles that you're not necessarily being hired specifically for this. Like, now granted, there are like technical lead positions, but generally speaking, you're not like applying to a job that is a technical lead. It's kind of like you're applying for a software engineering job, and oh yeah, by the way, you're going to be a technical lead too. So kind of the similar thing with a mentor. Now, teacher's a little bit different because depending on how you want to look at this, you could either be like a teacher in the sense that you're helping to teach and mentor, junior developers, or you could view this as like you go into academia and like actually teach classes and stuff, or even you create like some kind of online course material or something, but just like teaching in general. So you could definitely, make some kind of like legitimate profession out of it, like actually teaching, whether that's through some kind of online course, becoming a teacher at some kind of school or a professor at some university, something like that. It's definitely an option. But also mentors on there too. So mentor, of course, isn't, really thinking of teaching as a full-time thing, but more as like it's kind of one of those auxiliary responsibilities that you have. If you're one of the more senior developers on the team, helping, younger developers get up to speed on the code base, helping them learn maybe some more advanced programming concepts, things like that. The next one on here is DevOps engineer. Now, this one, kind of as I've touched on a few times throughout the runtime of the podcast, this one is kind of a marriage between developing software and managing infrastructure. So something kind of right up the home lab alley, if you ask me. So this one, of course, you're kind of focusing on the integration of the development side and the operations side. So back in the day, before DevOps, there was essentially two teams. You had your development team and you had your operations team. So what would happen is the development team would, write the code and, do some basic testing, and then they would essentially give that code over to the operations team, and the operations team would essentially be in charge of ensuring that code gets, deployed properly and runs, on whatever systems they're running on. And if it runs into any issues, they kick it back to the developers, and the developers make changes and then throw it back over the fence. And it was this constant, back and forth type thing. So the goal of DevOps was essentially to marry those two things together and create a seamless and a seamlessly integrated, pipeline, if you will, of being able to automate as much of that process as possible in order for developers to write more code. Now, there's a couple different avenues I've seen people take a DevOps engineer. One is very much focusing specifically on the pipelines themselves. So you're not necessarily, writing a ton of code on the main code base, but you're mainly focusing on, developing the CI/CD pipeline, ensuring that, once the code gets committed, it goes through all the requisite steps, ensuring you have things like your tests, your automated tests are in place. You're monitoring, the pipeline and the health of the systems that it's being deployed to, ensuring that, the deployments are going off as they should, the infrastructure is healthy, that kind of a thing. Ensuring you have the scalability in place, whether you're using Kubernetes or whatever. But one thing that we should also keep in mind that I've touched on before is DevOps is not about the tools, it's about the process. And I think that's one thing that sometimes people get caught up on is they're like, oh yeah, we use Jenkins and Terraform and Docker and Kubernetes, and we do DevOps. And that is what DevOps is to them. But in reality, it's just it's not the tools, it's the process, right? The idea of continuously integrating and continuously developing, and then, as you develop and integrate, that automatically goes into the, integration testing, building, deploying, all that good stuff. Because there's many different ways that you can do it. But of course, there are some tools that kind of stick out, but there are multiple ways that you can do it. Because, some people think Jenkins is DevOps, but then you'll ask other people and they'll say it's GitHub Actions or it's GitLab CI or, whatever the case may be. There's multiple ways to do it, but DevOps is, again, just those kind of principles and those methodologies. Now, there's kind of that aspect of DevOps engineer that I've seen, which is kind of focusing mainly on that portion of it. But then there's also the DevOps engineer I've seen where it's kind of, in addition to doing that stuff, you're also writing code that goes into said pipelines. Now, regardless of which one you fall into, the chances are, and one thing that I've been told before, when, looking at, DevOps positions and whatnot, is the value of being able to write code and understand code is very valuable for a DevOps engineer, but it's not, necessarily something that you have to be an expert in. But as long as you have, some decent scripting knowledge, that's definitely beneficial. But also, depending on, what your pipeline is trying to do, having an understanding of how to build and engineer software can definitely be beneficial in creating those pipelines. Because as I even, talked about earlier in the Nerdy Things segment, developing the CI/CD pipeline, you kind of have to know how to build the executable, right? So like if I didn't have the software, engineering and development background and already had gone through the process of understanding how to build my game, trying to create a CI/CD pipeline to build the game would be a lot more difficult than if I, of course, in the state where I currently am, where I already know how to build it, I have all the dependencies, listed out, and it's fairly trivial for me to do. If I didn't have that kind of a background, it would be a lot harder. So having, that background of understanding how software gets built and developed and kind of the principles and whatnot that goes into it can definitely be beneficial. The last two here are kind of a system administrator / site reliability engineer, and then network architect and network admin. So they're kind of in the similar vein, but also kind of have their differences. So of course your systems engineer and kind of site reliability engineer, making sure that your systems are operating like they should, ensuring things, basic security principles, are you practicing principle of least privilege? Are you, managing systems for regular standard users, installing packages, all that good stuff, making sure all your systems are up to date on their updates. If you're more on the site reliability engineer side of things, ensuring that, you don't trying to minimize downtime as much as possible, ensuring all of your infrastructure is up, if you're running like Kubernetes or something, making sure all the various nodes are up and running, and if you need to take something down, you have strategies to migrate things over, kind of really focusing on kind of managing that infrastructure. And then you have your network architects and admins, which again, this is kind of mainly focused on ensuring that, you're implementing things like VLANs, firewalls, working with, switches and routers and all that good stuff. So this is kind of where you can think of your CCNA type area, focusing specifically on the networking, architecting the network, ensuring that, your development devices are on, their one VLAN, your production devices are on the other one, and then you have like maybe a testing one as well, and just kind of designing what that network's going to look like to ensure things are kind of containerized, but also, ensuring good network security to prevent, things like lateral movement as well. And networking is kind of a interesting place because there are some on this list where the amount of actual programming knowledge you need is more or less. Some require, of course, more programming knowledge than others, but I would say the networking and kind of system administrator ones are probably the ones where you need the least programming knowledge, although it can be beneficial. Now, one thing that I think all software engineers and developers should know is basic networking protocols and technologies. Of course, you don't necessarily need a CCNA or anything, but also if you are working in, any kind of system administration or networking related tasks, it also kind of helps to have a software engineering background. Of course, I'm biased when I say that. But if you know how, software is developed and implemented, it can help you, at least in my opinion, better define, things like how networks should be laid out, or how to administer systems. But of course, that's my biased opinion as someone that is a software engineer. So those were some of the kind of main roles of what you can actually be doing as a software engineer. If you think I've missed any, definitely let me know, either in the comments on YouTube down below, or you can shoot me an email at contact@darkassassinsinc.com. I'd be interested to hear if you have any others that I missed, or if you fall into any of these categories. And the other thing that's also kind of interesting too about this is the number of cases where someone will have, one of these positions that has a background that has nothing to do with like computer science or software development at all. And they just kind of found themselves in one of these, career paths, which is always kind of interesting stories to hear. So if you have one of those, I'd also be interested to hear about them. But with that, let's go ahead and wrap this episode up and get back to our trivia question for the week. So UEFI is a specification that defines the architecture of the platform firmware used for booting the computer hardware and its interface for the interaction with the operating system. What does UEFI stand for? If you said Unified Extensible Firmware Interface, you got this week's trivia question correct. Kind of doing a little bit of a theme here between BIOS and UEFI. Next week will be different, don't worry. But yep, that was a trivia question. Hopefully you got it right. And if you enjoyed this episode or kind of got anything out of it, definitely be sure to leave it a rating and review, subscribe, like, all that good stuff if you haven't done so already. And be sure to share it around with friends, family, or anyone you think might find value in it. And also, if you have any questions or comments about this episode, or you have any topics or ideas for future episodes, you can shoot me an email at contact@darkassassinsinc.com. Link is down in the show notes. Or if you're on YouTube, you can just drop a comment. And that is going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.